Actually, doing each part, doing a part of this each stroke. Stroke when the piston is reaching near the TDC at the beginning of the suction stroke, when it is reaching near the TDC, that time you will have a condition where you have the piston which is decelerating. Okay, so piston is decelerating, piston is moving up. Because the piston is decelerating, the inertia forces are in upward direction, the scavenge pressure is in downward direction. But when the piston changes direction, piston starts moving downwards. Somewhere around the middle of the stroke, the piston is moving at a constant velocity. So the inertia forces are zero almost. But then when again the piston starts to reach downwards, at the beginning of the stroke, when the piston starts its downward journey, that time the piston is accelerating, the inertia forces are still in upward direction. But middle of the stroke, the piston forces, they become almost zero. It's moving at a constant velocity. Inertia forces become zero. Downward, almost reaching down, the piston is again decelerating. So from upward acting force, the deceleration causes the downward acting force. So these also change. It's not that during the exhaust, during the entire suction stroke, the forces will be in single direction. I'm just trying to give you an insight on the forces, how the inertial forces will be varying. Rest all you will have to go into the basics of your mechanics of machines or whatever, and then you will be able to find out. Compression stroke, again the three conditions I have shown. The beginning of the compression stroke, before the piston is reached the BDC, and then will reverse its direction. So that's the time the gas forces will be acting downwards. The inertia forces will continue to act downwards. Piston reaches the middle, the inertia forces become almost zero. The gas forces, they continue to act downwards. When the piston is about to reach the TDC, it's decelerating. So instead of the downward acting inertia forces, they change the direction, and inertia forces are now acting in upward direction. The compressive gas forces are still acting in downward direction, which are quite heavy. So piston is acted upon by downward acting force, net downward acting force. You can see that. Net force also, that is mentioned in each case. Then comes the expansion. So expansion also, when the expansion starts from the very beginning, from the top, the inertia forces initially will be in upward direction, the gas forces will be in downward direction. Okay. Then further down, you will find that the velocity here becomes constant, acceleration becomes zero. So that time the inertial forces become zero. Combustion gas forces are still downwards, but they have reduced in magnitude. Please understand that, because piston has expanded, gone down by this much of amount. Piston reaches BDC, there's further expansion, the gas forces have further reduced, but then piston is decelerating. So the inertia forces, again, they start acting downwards. Am I audible? Is my screen visible?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
I hope you are following what I am saying. It's not alien to you. You have all studied about the same.
Yes, sir.
Yes, sir.
Yeah. Anything with the help of these diagrams, various stages, I just try to say that at what point, what will be the direction of these forces. That's what I have done on these slides. So exhaust. So doing exhaust, what will happen is at the beginning of the exhaust stroke, the piston has just reversed its direction. It starts accelerating upward. So the initial forces will be acting downwards. And the gas force also is acting downwards. But middle of the stroke, the initial forces, they become zero. Again, the gas forces are still acting downwards, but they are very small in magnitude. Here also, it's very small in magnitude. At the end of the stroke, the initial forces, they start acting upward. The gas forces are downwards. So they are trying to actually cancel out each other, more or less. So though I have mentioned the net force is in upward direction, but net force may be close to zero. Okay. And then you will have ample amount of lube oil flowing over here. So at the end of the exhaust stroke also, that is the beginning of the suction stroke, that is the time the lubrication, the lube oil starts flowing in ample quantity into the gudgeon pin bearing and continues to cool and lubricate the bearing well. Is this clear till now? Any doubts, any questions? You can ask me. Anything?
No, sir. No, sir.
No, sir. Okay. So I'll move on to the crosshead bearing lubrication problem. Okay. So from crosshead bearings, you will find that crosshead engines, the resultant inertia force plus gas force is always acting downwards. Never doing the two-stroke cycle will come an instant where the force will get reversed. Always 100% of the time, inertia plus gas force acting in a downward direction, 100% of the time. Crosshead bearing is always under constant downward load and giving a real challenge to the, oil being allowed to flow into the bearings. The bearing, moreover, does not go more than few oscillations, few degrees left and few degrees right, not more than that. And that gives a very small oscillating speed also to the bearing. So you get a very low sliding speed and you get a very poor pumping effect. In fact, that hydrodynamic effect is poor, not very large. So let's try to see how the forces are acting first. 6 conditions I have given. Just try to have a look. Piston started moving upward. Scavenge air pressure acting downward. Piston is getting an acceleration, so upward. So inertia force acting downward. Net force is downward. ये है purple color net force का है. ये this one is for the piston movement. So please don't get confused. This hollow sign is for piston movement. The piston movement का sign है. Net force purple. All is net force downwards only. So this is the first condition. Second one. Piston is somewhere middle of the stroke. Upward direction. Inertia force has become almost zero. Compression has started taking place. There is a heavy gas force acting downwards. Net force is downward. Am I audible?
Yes, sir. Yes, sir.
The third, piston has reached the TDC. So piston is now decelerating, coming to zero velocity. Okay. So inertia force is also acting in upward direction because piston is decelerating, but the very heavy combustion force is acting in downward direction. So very heavy force minus a lighter inertia force, the inertia force is comparatively much lesser. So still you have a net downward force, net downward acting force. And moreover, you have a, very, very heavy combustion force and very, almost zero velocity. Zero velocity may be there for the piston, but in fact, the swinging velocity of the bottom end bearing of the top end bearing of the connecting rod top end is very high at this point of time. Okay, I will not confuse you. I'll move on and then maybe later we'll discuss that swinging velocity. Then the piston started to reverse its direction. Now piston will start accelerating in downward direction. So inertia force is still acting in upward direction and the combustion gas force is still acting in downward direction. This is heavy and this is comparatively lighter. So heavy minus lighter, net force is again in downward direction and it's a heavy magnitude. So point number 5, point number 4, the force is still in downward direction. Point number 5, let's see point number 5. The piston has reached the midway and the piston is moving almost now at constant velocity, giving you a net zero inertia force and the expansion gas force. Right now, the exhaust valve may not have opened, so it's still a considerable force which is acting in downward direction. Point number 6. The piston has almost reached the BDC. It is decelerating. because it is decelerating. The inertia forces acting in downward direction. The exhaust gas forces and the scavenge air force that is acting in downward direction, giving you a net downward acting force. Though at this point of time, the force magnitude, magnitude will not be very high. So this is the only time when you have the oil flow in sufficient quantity in the bearing, but still the forces are in downward direction. So as you can see, you see any part of the two-stroke cycle, there is never a relief of load on the crosshead bearing. Of course, crosshead bearing yahan par nahi hai, it is down below. That is not shown over here. Crosshead bearing is down below, but the crosshead bearing never gets relieved of the load, downward acting load. And you always have a load which is acting in direction, causing the oil film to be squeezed out. Only thing when it is the piston reaches the BDC, that's the time the load is reduced substantially, and that's the only time when the oil can flow in at insufficient quantity to cool down the bearing and lubricate the bearing. Am I clear on this?
Yes, sir.
Please ask a doubt if you have, because this concept is very important. This question is asked in your class 4 exam. This question is asked in your class 2 exam. This question is maybe asked in your class 1 exam. And this question is one of the favorite questions, which is there in all your, whenever lubrication problem comes. This is one of the hot favorite questions of the examiners. Vivas, interviews, and, exams. Okay, I'll move ahead. Nobody is asking me anything. Now the question is, we know problem is there. We know that crosshead bearing is going to give us a problem. Then what is the remedy? Can I allow my crosshead bearings to have a very short life? Can I allow my crosshead pins to get damaged and scored? Obviously not. So engine makers, they have done a lot of researches since past maybe half a century or more, and they have done a lot of changes. They continue to incorporate changes in the design of the crosshead bearings and all. And each maker, they work in their own way to cater to these problems. First thing is the actual oil supply grooves which are there.